For this lecture, I intend to describe and demonstrate a fundamental concept in object-oriented programming. The key word of this lecture is encapsulation, and it is a notion that every software engineer needs to fully understand from day one. Encapsulation is one of the fundamental ideas of object-oriented programming. When we design a type or an object to hold data, we are simply not grouping variables together. We are defining a coherent container filled with individual data elements that together describe a real object. That container should protect its internal state, enforce its invariance, and just by inspection should communicate its intent and purpose very clearly. I am often reluctant to use the subjective phrase, good code speaks for itself. However, I think it does apply for simple encapsulation of objects. Organization is key, and we want to bundle related data into a single object rather than to pass loose primitives around in the system. Passing raw strings, integers, and booleans independently weakens meaning. Passing a structured object strengthens meanings. We also want fields to be private and ideally immutable. Once an object is constructed, its state should not change unexpectedly. Validation must occur at construction time. If an object we are modeling exists, then it obviously is valid. Also, we must prevent partially initialized objects from leaking into the system. Encapsulation is not about hiding data, it's about promoting correctness, readability, scalability, and maintainability. Objects model real-world entities, and real-world entities tend to grow in complexity over time. A simple object with 3 fields is easy to construct, but what happens when that model grows to 10, 15, or more fields? For example, perhaps the HR department for a company initially only needed a few bits of information for its employees. As the organization grew and regulations changed, the HR department had to collect more and more information on its employees. The list of parameters for the constructor become long and difficult to read. Positional arguments introduce risk, especially when multiple parameters share the same type. Poor construction designs lead to subtle bugs. Fields can be swapped accidentally. Optional data with null values become awkward to handle. Validation becomes scattered. Construction patterns are not a stylistic preference. They directly impact maintainability, scalability, readability, and various other things that we need to hold true inside of an organization's code base. Traditionally in Java classes, we define private fields, implement explicit constructors, and generate getters manually. This approach is powerful and flexible, but it comes with a cost in the form of boilerplate overhead. As classes grow, the amount of repetitive code grows. While this approach enforces encapsulation, it does not necessarily optimize clarity, and it certainly does not speed up development. To help reduce the boilerplate overhead associated with encapsulation classes, Java introduced records. A record automatically generates private final fields, a canonical constructor, assessor methods, and proper implementations of methods like equals, hashcode, and toString. More importantly, records explicitly communicate value semantics. When you see a record, you know this type represents data. It's an encapsulation device. It's not a behavior-heavy object with a mutable identity. Records make immutability the default, and that is a powerful design choice. They reduce noise, so the structure of the data becomes the focus. Despite the concise nature, Java records do not eliminate every design concern. Even with records, constructors remain positional. If a record has many parameters, those parameters must still be passed in the correct order. With enough fields, readability declines again. It becomes difficult to scan a constructor call and immediately understand which argument corresponds to which component. So while records reduce boilerplate, they do not automatically solve the clarity problem at the call site. In real systems, data models evolve. We begin extracting nested value objects. We compose types to reflect structure more accurately. Instead of one large flat object, we introduce smaller focused components. Composition improves modularity and makes reasoning about the system easier. But even with composition, construction can still become complex, especially when multiple nested objects become assembled together. Immutability remains desirable, but the path to constructing immutable objects becomes more complicated. Another practical concern is that data does not always arrive at once. In distributed systems, microservices may return partial information at scattered points in time. In user interfaces, forms may collect data across multiple steps. In streaming systems, fields may arrive over time, oftentimes not in the same order. This means we sometimes need staged construction. We need a temporary mutable representation while gathering information, but we still want the final object to be immutable and valid. The tension between staged input and immutable output motivates the builder pattern. In software development and in general engineering, it's important to keep in mind an important concept known as separation of concerns. The builder pattern separates construction from the representation. Instead of calling a constructor directly, we introduce a builder, a mutable object responsible for gathering data. The builder exposes affluent setters. These methods allow for fields to be set in any order. When the object is ready to be built, we call build. That method performs validation and introduces the final immutable instance. The key idea is this: mutability during construction, immutability after construction. Class builders provide named construction, which makes call sites self-documenting. They remove dependence on parameter order. They centralize validation logic in one place. They allow optional fields without requiring dozens of overloaded constructors. And they make large object creation much more readable, and in done correctly, almost like a narrative on how to use it. Notice how fluent construction reads like a description of the object being created. Builders do not replace records, they complement them. Records express value semantics. Builders improve construction clarity. Together, they create a clean, safe, expressive design. Now we will move from theory to practice. Up to this point, we have discussed design motivations and architectural reasoning. In the demonstration I'm about to provide, you will see how these ideas translate and evolve into real code, and how a model can evolve from a traditional class to a record-based, builder-driven design. Focus on how the readability changes, and how the construction becomes clearer as we refine the approach. The code in this demonstration has been versioned and pushed to a GitHub repository. You can find this repository using the link or QR code displayed. Okay, so if you use the link or the QR code that I provided, you should have arrived at a repository like this. Now, I would like to explain how my repository is laid out for this exercise. If you look, I've actually got tags here where I started out with version 0.1 and then went to 0.2, then 0.3, then 4, and then finally version 1.0. That version 1.0 is kind of where we end up at. Now this is version 0.1. This is effectively where we start out with that very basic kind of naive implementation in Java where we use a bare bones class to encapsulate some data. And it's kind of hard to read and it's quite lengthy given all the parameters. Then we decided in version 0.2 to convert it to a record class. And then in version 0.3, we use nested record classes to help readability and encapsulate data in a more meaningful fashion with storing human personal information. And then in version 0.4, we add class builder patterns to the encapsulation classes. And then finally in version 1, I show some string formatting techniques to help nested classes kind of build up strings as far as producing feedback to the users. So let's go ahead and let's clone this repository. You guys are free to fork it if you want to, but I'm going to clone mine. Go to your terminal. For you guys that are using Windows, this is probably Git Bash. For those of you guys on Apple and Linux, it should work just out of the box. So git clone. There we go. Great. Now we pull up IntelliJ, and obviously I did pull it up before, so I'm going to basically open this. And I'm going to navigate to the directory that contains the POM file. Now, one of the great things about IntelliJ is it makes like viewing things on the remote repository very easy. So if you look, I've only got the main here, but on the remote, you can see that we've actually got some tags available. And this is where you see the version 0.1 all the way up to version 1. So let's suppose that we want to use the command line to check these out. So I'm going to do git checkout version 0.1.0. So I'm going to go down to source. I'm going to click source, and I'm going to show you all these nested folders. So basically what we have is we have a package named Big Corporation HR, right, or Big Corp HR. So I look in here, I only have one employee class. I think this text file is kind of irrelevant. I was going to make some notes for you guys there, but I decided I'd just say it out loud. So disregard this file. In employee class, notice what we have. All that we do is effectively define a bunch of fields associated with an employee. So private final, employee ID, private final, the first name, middle name, last name, phone number, email address, street address, city, state, zip code, country. Then we have the birth month, birth year, birthday, and then we have the hire year, hire month, hire day. And then, of course, as you know, anytime you work someplace, they want to have an emergency contact or two. So guess what? We also have their first, last name, phone, email, street, city, state, zip code, and country for these two guys. And then look at the constructor that's required to actually set all these things. A person would actually have to go through and set all of these to build up this class. They would have to set each one of these, not just remember their position and get them in order, but remember their type and everything else. So if you go over here to the main class, you'll see that I've done exactly that. I created the employee class. I called it John Doe, representing our John Doe employee, new employee, and then look how the the constructor gets called. The employee ID, the first name, and all of this. That's really kind of a nightmare, right? Well, what happens if we go over here to employee class and I decide, you know what? We have the middle name for the employee, but maybe if we need to have a middle name for the emergency contact. So I could maybe have let me turn completions off here. And we're going to have emergency contact middle name, and then we'll say emergency contact middle name. Now what I've got to do is I got to come up here and I got to create this middle name in here. So private final string okay, and then man, this is a nightmare. I've actually got to go in this constructor and I've actually got to figure out where to put this. So I keep looking, I keep looking, I keep looking, and then it looks like I found first name, then last name. And so it looks like it's going to have to go in here somewhere. Now in data, I say we've already got a little bit of a mishap. So it's already defined in this scope. Oh, sorry. This should be middle name. So as you can see, this wasn't so terrible, but imagine if we were talking about a record class where the fields were not so like well defined, where we're using words like we already know, like our first name, last name, middle name. What if it was like the IDs for different things that an employee may belong to, different organizations? At some point, figuring out where these should go in the constructor and all these other fields, it would become quite a headache. And then not only do I have to change it here, but I had to go back to my main Java and my driver file, and then I had to look to see where that emergency contact middle name was and all that. And notice here, even when my ID is helping me, notice what happened. It says emergency contact first name, but since I've got a misalignment, it's now calling it emergency contact middle name. So I would have to actually stick something in here where I could say fake middle name, right? And then finally put the comma there and then fix it. So as you can see, this would be quite a nightmare to kind of update if the fields were not so familiar to us with things that we use every day, like our name, first name, last name, birth month, whatever. Okay, so what could we do to improve this? Well, I think one thing that would help is instead of having this class where, look at all this, for each one of these things inside of this constructor, I then had to set this, which is the variable, which is the class variable, and the constructor parameter variable. I had to like set those equals so that way I'm setting the class variables to hold this data. And then not only do I have to set all that, look at all that typing we had to do just to do that. We then had to validate the employee ID, which it looks like it needs to be a number between this and this. So it's a 9-digit positive integer, correct? Sorry, I think it's a 7-digit positive integer. I got that wrong. A 7-digit positive integer. And then we had to validate the phone number. And then we had to validate the email address. And all this is done by regular expressions, by the way. And then the zip code. And then we had to validate the year, right? Now for the year, I'm actually kind of using the local date thing. So that's kind of helpful. And then for each one of those things, I had to construct an assessor or a getter effectively. So that way I can get the individual components out of this, right? And then obviously, if we're going to have this data, then we need to have it print as a toString. So let's go over here to main and show how this works. We'll hit the play button. Give it a second. And then here it goes. It prints everything out, right? Now, definitely not very neat and tidy, but that's okay because our class is somewhat of a mess. It took forever just to create the class, so this is kind of something thrown together, right? Okay, so how can we improve this? Well, I think if there was like a shorthand way of creating this class, so let's be clear, what do we have to do? I have to define the variables inside of the class, the first name, last name, street address, all of that, then the contact information and all of that. And then I have to basically use the exact same things up here, and I have to create the constructor components that gets passed in when the class is initialized. And then I had to take each one of these and set this dot that variable ID equals to that variable ID to set the class variable equal to the parameter passed into the constructor. And then we go down here, and maybe this right here cannot be avoided, so that has to stay. But then we get all the getters. So it says get employee ID, get first name, get middle name, get last name. And all of this becomes quite a little bit of an overhead, especially when it seems like I just keep typing the same thing. Well, let's go ahead and let's check out version 0.2. This is where we're going to create the record class. So get checkout version 0.2.0. Oh, and it says I made some changes. I'm not going to say those changes, so I'm going to stash them. So I'm going to do get checkout version 0.2.0. So it doesn't look like a whole lot has changed. In fact, it's not, but let's look and see how much more concise this is. So notice that the keyword here is no longer a class like it was. It's now public record. So before this said public class employee. Now look at what the employee does. Beforehand, we had these opening braces. Now we have like essentially an open parenthesis. Notice that all I do is just basically list out the variables that I need to hold data in. Notice that I don't have to define the constructor. Notice that this part right here, the constructor that was here, I left the notes in here so you guys can see, is no longer there. Because why? If we create a record class, it's automatically going to assume that in order for these variables to get implemented, there's going to have to be a constructor that sets them. So guess what? It goes ahead and does that for you. Notice that I don't declare these as public or private or final or not. It does it automatically. In a record class, they're always considered to be private and final by default. You just have to declare their types as a parameter, almost like you're setting up the constructor for it. And then notice that I still had to keep my validation mechanisms in place. Not a big deal. And then notice that there's no getters. There's absolutely no getters here. So we have public toString, which is basically doing that like we had before. So notice that this was the output before. And notice that I'm going to run this output now. So to be clear, notice that all I did was I still created the constructor the same way. Didn't help us any with the constructor as far as where we're calling the call site issue is still there. So we have to keep all this straight. But notice that the record class simplified this encapsulation class quite a bit. Okay, so then we run it, and effectively we got all of this. All right. Notice that it's almost identical, or it should be identical to what we had before. Now, to be clear, how do we actually get an individual field? So notice that we said we don't actually create the getters or the assessors directly. That's because they're automatically created for us. Because if I wanted to get in the other class, when I wanted to get first name, I created a method called get first name, and it returned it from the class. So guess what? All of these are automatically created as a method that's serving as an assessor to where each one of these variables, all you have to do is just put a set of parentheses behind it, and you've got the method name for the assessor or the getter for that component of the class. So if you look in main Java, notice that I'm saying, what if I want to get John Doe's emergency contact #1 phone number? Notice that that emergency contact phone number is defined here. So guess what the record class automatically generates for us? It automatically generates an assessor to where we just use that same, to be clear, that same exact variable name is the method name, except you just put two parentheses open to show that it's a method. So if I wanted to get employee first name, how would I get the first name? I'd go over here to my employee class, and I'd see the first name is this, so I could actually get system.out.println John Doe, get the class identifier, and then notice how This is helpful. Notice that all of these with parentheses next to them, and it's got the method symbol here. Notice that we're not defining any methods in here except for these validations, but they're private, so we won't be able to use those directly. Notice that they're not here, as I said before. That's because these are automatically created with a record class. So we could say, start typing it, first name, and then when we do this, you'll see that it will actually print out the first name of the person in that record class. And notice that it's John. So we got the first emergency contact for number one's phone number, and we got the employee's first name using the automatically generated assessor method that comes along with the record class. Okay, so that makes things much, much more easier, right? Well, let's go back and let's think about something. We first had to deal with this. Like, this is a complete nightmare to have this many parameters in a constructor. And believe me, that as things grow more complicated, this may not even be considered a lot. Now, I would say for anybody that's got any kind of professional development background, this is probably so much that you probably would never, ever want to do this many, right? This is just begging for someone to create errors somewhere. And let's keep in mind, errors can be somewhat subtle because in a lot of development environments, everything that comes in may actually be an integer. There may be very few strings, so you may be dealing with every parameter being an integer. So while it may pass some unit tests just because some ranges for integers may overlap, you're begging for errors. So I would say that most seasoned developers will say creating a constructor in this kind of large-scale fashion would just be begging for problems. So let's go back and look at the employee and let's see how we can kind of fix this. Here's the first thing that kind of leaps out at me. Notice what we are doing for the employee. We're getting the first name, middle name, last name, phone number, email address, street address, city, state, zip code, and country. This personal information dealing with humans, like their first name, last name, and all that, maybe we can encapsulate that in a separate class. That way we just basically define the contact information for the employee, the contact information for the emergency contact number one, and then the emergency contact information for number two, right? Okay, so that's exactly what we're going to do in version 0.3. We are going to create another encapsulation device where we're going to take the personal information for a human and encapsulate it, so that way some of these fields can get removed and placed into something a little smaller. All right, so let's go back, and I'm going to do git stash because I think I made some changes that I don't care about. Now I'm going to do git checkout version 0.3.0. Notice that when we did this, another class actually popped up, and it's called contact information. So what was common, remember, what's the idea of object-oriented nature, object-oriented refactoring? Take things that can be reused, make it modular, and allow the things that can reuse it to reuse it in meaningful ways. So remember, when we were back in our employee, we had three people. We had the employee, emergency contact one, and emergency contact two. Each one of them effectively had a first name, middle name, last name, all the way down to country, and then maybe they have a birthday too if we want to have it. Who knows? Maybe work for a company where we want to send the wife or the spouse an email that says, hey, happy birthday, we're glad your spouse works for us. Whatever, who knows? There's all sorts of gimmicks that happen in these places. All right, so let's take a peek. Now we have first name, middle name. We didn't actually get the middle name for the emergency contact, but that's okay. We could maybe have it if we want it, or we could just leave it null. Also remember not having the birth date, so perhaps that's okay too, or maybe we want to just leave it null. Maybe it's not important. All right, notice that our constructor here, you can actually create a new constructor if you wanted to, but we're leaving it default. You can actually make it reject things that are null, that have to be present, and disregard things that don't. So basically, if first name needs to be set, then we can recreate a constructor down here that says, if first name is null, then throw an exception. But right now, we're just trying to keep things simple. So now, look at how we encapsulate this data. Now go over here and look at employee. Notice that this record class called contact information, notice now how much shorter this thing becomes. All of that redundant data about first name, last name, middle name, street address, telephone, email, all of that has been encapsulated into the contact information. So now we just declare inside of our record class, contact info, the personal contact for the employee. We keep the hire date, and we're storing it as a what? The local date. I mean, Java's already got something to handle dates, might as well use it. And then we're going to have a contact information for the emergency contact 1 and emergency contact 2. Notice how much simpler this employee class got using the reusable data provided in, or the reusable class that we created for contact info. Now notice how the toString is working. Notice that there's not as much here. Notice that I'm actually relying on the contact info class to actually print its data. So if you go over here to contact info, notice that contact info actually has its own string builder. So guess what? Whenever you're an employee, you basically say, okay, employee ID, which is right here from our previous run, we have employee ID. And then when it comes down here to printing all their contact information, guess what? We just reach out and ask the contact info class to print it for us. So we're just going to return back or append the information from the contact info's toString method. So all of this information is coming from contact information, gets forwarded right into the employee method, and we're all set. Notice how much cleaner and more concise this is. So guess what? Emergency contact 1, it was also a contact info record class. So we're just going to rely on that contact info class to does its own printing. All we're going to do is have it pass it in from there, and we're going to forward it right into our string builder. Great. Okay, so now we go to main Java, and let's see how we can actually use this. So notice that we have our employee. It's not one gigantic constructor. We have the contact information for the employee. And this is where we put in all the information for the employee. Notice that the birth date is passed in as 1985, 5th month, 15th day. Notice that over here we have emergency contact information for Jane Doe, perhaps the wife of the employee. So we put all of that contact information inside of another contact info. And then we have maybe the neighbor, contact information for emergency contact number 2. And we encapsulate all that. So notice that we actually don't care about their middle name. So guess what we do? It's still a field inside the record. We just pass it in as what? Null. Now, with primitives like integers, you can't pass in null, but if it's like something like an integer, you can find ways of creating semaphore flags to say null, or you can use what we call a box primitive to allow it to be null, whichever case you want to use. So we've essentially created the contact information for the employee, the contact information for the emergency contact 1, the contact information for the emergency contact number 2, and then guess what? We construct the employee class, the record class for the employee. We put in their ID number. We just simply pass in their what? Their personal contact information. What is this? This was actually their hire date. We don't need their birth date because that's common to everybody. Everybody has a birth date, but not everybody with this company has a hire date, such as these guys. So it wouldn't make a difference. So it really makes sense to put the hire date into the contact info because not everybody we're going to be storing data on has a hire date. They may have never been an employee. And then what do? We pass in emergency contact 1 and emergency contact 2, and then we print out the information. So what's this? Try to kind of look at this visual right here between here and here because this is what it looked like before we refactored everything. Now when I run it, let's spend a little time on making this a little bit cleaner. So I agree, this is not great, but at least everything's on one line, perhaps. So your question may be now is, given that we have nested classes, how do we get the phone number for like an emergency contact? Because after all, inside of our class, the emergency contact information is actually stored in the contact info. But remember, given that there's a class variable called emerge contact 1, that means there's a method that can be called with just those parentheses. I know that's an error, that's bad syntax, but it basically has a method that looks like that. And what does that method return? It returns the same type as this. And so since it's returning that type, we could then ask contact info for the phone number. So look and see how we do this in the main Java class. Access an emergency contact phone number via the emergency contact record. So we're going to do system.out.println emergency contact 1 phone. Look at this. We have John Doe, which is the record class. We use one of the automatic getters for the emergency contact 1, which is in fact a what? Contact info record class. And then from that contact record info class, it has all of these parameters. So I could do dot, and then I could find the phone number. So watch what happens. I print this and notice what happens at the very end here. I get the exact same phone number that I've been getting. Assuming I kept these records straight. Who knows? I may have changed them, but hopefully you get the idea. All right. So now we see how we can nest records to encapsulate data in kind of a nested stage. That way we can reuse these record classes in a meaningful way. I think part of this lecture was about using builder classes. So if somebody was to just look at your main driver file, and let's be careful about things, this package right here, but it could actually be hidden somewhat. Publish this to a GitHub as a package. Notice this is not very informative. Even though it's a very small constructor, it is not informative. You kind of have to know that this is the employee ID, which IntelliJ helps us with. But here, this is going to be a contact info. This is a date mechanism. It doesn't say hire date. And then this is what? Emergency contact 1, emergency contact 2. If somebody did a good job with naming variables, maybe this is already, we can deduce what this is. So how can we fix that? Well, it turns out that builder classes are exactly what we want. So guess what we're going to do now? We're going to go and stash what we've changed because I don't want to save it. It turns out I didn't do anything. And I'm going to do get checkout, and I'm going to do version 0.4.0. So now I've checked out version 0.4, and this is where we're creating builder classes, okay? So let's go back and let's look at contact information, and notice that there's going to be a few more things here. Notice that none of this changed. We still have all these parameters that we have in here along with our tops, and then we still have our toString, which really hasn't changed. Okay, so just for a moment, everybody assume that you're just taking my word for this one. Just start out with that. That's as simple as it gets. And then basically you create public static class builder, right? So public static class builder. Now you're going to say all the parameters that you had up here, and you're going to label them private. We don't want to make them final because here you want data to be mutable. You want it to do whatever. Until you finally get everything built, then you're going to say build it, and it's going to return back a record class. So just make it private, and every parameter that you have up here, put it down here and label it private, same type, variable name. And then make the constructor just basically nothing. Then you're going to say public builder, which is going to return back an instance of this, and you're going to say first name, string first name. So what does that do? This is actually going to set the builder class version of the variable equal to this parameter. Now here's the key. What's it going to return? It's going to return back builder, but not just a new builder, it's going to return back this builder. So with this, what's happening here is public static builder is going to have a method called builder. Public static is going to, a method called builder is going to return back a type called builder, and it's going to be a new instance of the builder subclass. So the builder subclass is static, which means you can use it without creating an instance of the record class. You set all the variables that are inside your record class up here inside of this one, except you do have to declare them private because you're kind of creating a little bit of a classical construction here. Then the constructor, just leave it alone. Now public, you're going to have a method called first name, but it's part of this subclass called builder. It's going to return back a builder. So whenever you pass in the first name, it's created an instance of this static class builder, but every time you set a parameter, it's going to return back this, but you're going to sequentially set all these parameters, chaining them together with methods, and you're going to sequentially build up the builder class with all these parameters in any order that you want to using these methods. And then finally, once you get them all built, you then call something called the build contact. But notice that this is not going to return builder or this. It's going to return back an instance of the original record class. So we come back down here, and guess what? This is where you basically, for one time only to help all of your users, you actually call the constructor of the record class, and you make sure that all the variables of your subclass here are nicely arranged into the constructor for the contact info, and then it returns back an instance of the contact info class. All right. Now to be clear, I'm not even sure if I said all that verbally with 100% accuracy, right? There's a lot going on here. So this is one of these instances where you have to actually kind of set and really make sure that you understand what's happening before you move on. Now let's look at what happens in the main Java class while we're building record information. Notice here that we got contact info personal because we're going to be generating a what? A contact information class record. But guess what we're going to use to build it? We're going to use the builder subclass. So we're creating an instance of the builder subclass. So every time that you pass one of these methods in, you're going to get first name John, middle name A, last name Doe, phone number, email address, all of this. If the birthday is important, put it in there. And then once you do all this, and by the way, here's the cool thing, is it won't even make a difference if you get them out of order because it won't matter. It's going to basically set these individually, and then once they all get set, you then do what? Do .build. Now you didn't have that luxury whenever you were doing a constructor. When you were doing the constructor, you had to make sure all these parameters were set in place, and you didn't have the help of the setter for the builder class to help you along. So after you sequentially chain these together, so you're doing builder, so dot, 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 each one of these is basically returning to the next method this, which has been updated with the new parameter. So once they're all done being built, you call build. And what does build do? Build essentially takes all these subclass parameters that have been set in any order that you want using these setters, all these parameters have been set. And then once you get them all, you call the build method. And what does build method do? It basically calls the constructor and returns the contact info class type with all this data populated into it. So the benefit is your users now have a meaningful way of knowing what the parameters are setting. They can change this as many times as they want to until build is called. So basically you have mutatable data until you build the class, and then it becomes immutable. And just keep in mind, if you were to wait on network calls, like suppose one network call returns back the first, last name, middle, then another network call brings in the contact, phone, email address, and you're having to splice all this information from different records, maybe a credit report, a driver's license, a DMV record, who knows. You're having to construct all this together from different sources. That means this data is going to be arriving at a different point. What you would have to do in main is you'd have to actually set a variable to hold all this until you got all of it, but then that would kind of almost defeat the idea of having a record class. But the record class is so useful, you might as well put the temporary variable holding inside of this builder class. So it's serving multiple functions at the same time. A way to help your users, your developers know how to use your class. So it'll help your users actually keep track of what needs to be filled in. And more to the point, they don't have to be stored in any order. So when network calls happen, as most of you know, you can't really rely on them coming in at a certain point. So once you get a notification that all these network calls have got all the data they want, you can set them as the data comes in using this class builder, but then you use the .build once you get a notification that all information has been brought in. .build converts it from all this temporary storage to this builder class, and it generates an instance of the personal record. Notice one thing we didn't do. Notice that middle name was never a big deal for these folks on the emergency contact, nor was their birth date. So we just didn't set it. And guess what happens when build does it? It automatically, if it was never set, it's null in the builder class. So when it gets passed to the constructor, it's null in the record class too. So good. And then we have the same thing for the emergency contact. And then what do? We have the exact same thing for the employee class, where we created a builder class. Remember, this is kind of like, just as a general thing, public static builder. Whenever you call the builder method of this class, you're going to initiate a builder class, which is a subclass of record class. Create an instance of it. Remember, its default constructor is effectively nothing. That's why you can just have the parentheses here. And then that creates a container. This container will hold all this bits of information, but they're not final. So it means they're mutatable. And how do you set them? You set them using the builder class's setter methods. Once all the setter methods are done, you then call the subclass's build mechanism. It validates the employee ID. You can actually move this validate employee ID up to here. And then you have return new employee, where you pass all this information and you've constructed a new employee record. That's where the data is no longer mutable. Now, here's the cool thing. What happens if you were to pass this validate employee ID? That's where we got to have like a 7-digit number, right? So if you were to pass this up here, guess what? Whenever somebody's actually going through the process of doing this, Beforehand, you would basically call a constructor and then the constructor would vomit up 10,000 errors for all the things that went wrong. But if you used a builder pattern to where the validation mechanisms happen inside of the builder class on the setters, like this, then that means once you called this, you would actually get an error for here. So if you're a developer in the development stages and you're trying to work it out and you set this and it vomits up an error, that means you know exactly where the error happened. It's employee ID. So you go back and fix that. Then you come down here. This one passes, but then this one has an error. Well, it must be something wrong with this class, so you can look into it further. There's so many benefits to builder patterns that it's hard to ignore their value. It allows other developers to know how to use your class, record class, your encapsulation class. It helps other folks keep things straight. They don't have to put it in order. And it also happens whenever we have asynchronous calls to network streams and data has been coming in kind of maybe in an unpredictable fashion or from different parts. These builder classes have temporary storage that kind of help us out organize things in an appropriate manner. So notice that this builder class did not change anything about the record class. It just made us a helpful tool to build the record class. So none of this down here changed. So it should look like nearly the same output as what we had before. Okay, now one last thing I want to show you. So this is kind of stepping off the record class just a bit and the builder class just a bit. But if you're going to be devising record classes, then you should probably be familiar with how to allow string formatting to handle within the class itself. I've already demonstrated a little bit, but I want to show you something where you could play kind of little tricks if you're generating a JSON object or if you're generating like a string formatting that needs to have a certain look to it. So I'm going to go ahead and check out. So I don't know if I made any changes or not. So I'll do get stash to stash all the changes that I made. And I'm going to do get checkout and I'll do version 1.0.0. This is where we kind of feel like maybe we got some production code happening. All right, so now we've got the same classes, but look at what we do. We're going to use some overloading here of the toString method, and it's up here somewhere. Okay, notice that my toString method, we're overriding the default one toString, and notice what it's returning back. It's returning back another method, an overloaded method. So we're overriding toString, the default one here, and now we're doing what? We're overloading toString to accept a parameter. This parameter is 0, which means indent level. If I just wanted to print basically one employee, let's go up here and look. If I wanted to print out just emergency contact 1, let's see what happens. Instead of this, I just want to print out emergency contact information. There. And I hit play. I'll comment this out so we don't get anything confused. Notice that basically we're just printing out Jane Doe, this, and this. It's just kind of the basic information. But whenever I want this to be printed out with like John Doe, maybe I want some better organizational skills. So that way when I print this, I get something that looks like this. Notice that we print the employee ID, and then we tab over to give all the information related to this employee here. The employee contact, it gets printed here. The emergency contact 1, it gets printed over here, tabbed over, emergency contact 2. We can achieve this by allowing contact information to be aware. If we're just wanting to print toString, that means we don't want any indent level, so we're going to make the indent level 0. And then it calls toString indent level whatever with 0. So it basically creates the exact same thing, except notice here that I do the indent repeat \tab, which is the character for indent level, and we're repeating it that many times. So each time one of these things print, I'm doing what? I'm indenting that number of tabs at the start of each one of them. So that way it shifts everything over. So notice this indent is basically at everything that I'm printing is at the beginning of it. Indent for the phone, indent for the email, indent for the address, so on and so forth. Okay, and then at the end of it, I basically return the whole string builder toString. Now look at what employee does. Employee, when I'm calling it, notice that I've also overloaded the toString. So if the toString, I've overridden the default one to do this, but all it does is call the overloaded version of toString that accepts a parameter for tab level. So it calls this indent level. Notice that I do the exact same thing where I repeat the indent level that many times. I just print out employee ID, which in this case will be 0. But then I want to increase the indent by 1 and then add that to the indent string that I created. And notice that everything I'm printing here is going to have that indent with it. And this is how we can start aligning things to where individual classes can be indented or not. But if they're nested with other things calling them, because remember, what is this thing calling? It's calling personal contact dot toString indent level +1. So employee contact information will be an indent +1, right? Okay. Notice that all those four are the same pattern, because if they're being printed from the employee class, they need to behave a little bit different with the indentation mechanism as if they're being called directly from the contact info class. So hopefully that's some sort of insight. Again, I expect that you probably need to play around with that to really kind of understand what's happening. But that's the sample code that I provided. Hopefully this makes sense. Hopefully you guys can kind of deduce what's happening there. It's these kind of patterns where we override and overload and then refactor to record classes and do nested encapsulation tools to where we can start building very strong frameworks without a lot of overhead. And not only just overhead, but as our models and our representations of real world data that we're having to model in our code, as they grow more and more complex, as things naturally do, we get a better control over it. Because if we're using builder patterns, then it doesn't really matter how much it expands. We're only going to have to change the code inside the class itself, to be quite fair, right? All right, so hopefully you guys see the power of this. Hopefully you guys see the usefulness of this. And it's kind of this mechanism to where you're learning how to become a more mature developer. So anyway, I hope you guys enjoyed that, and thanks for watching my demonstration. Today we examined encapsulation, immutability, records, and the builder pattern, not as isolated feature, but as parts of a design progression. Good software design is incremental. We improve clarity, we reduce boilerplate, we preserve correctness, and we make construction intentional. So thank you for watching, and I look forward to your questions and comments.